Hi, I'm Francis Potter, Solution Architect with GitLab, and today we're talking about application security at high velocity, my favorite topic. So I hope you enjoy. Let's talk about velocity first. Software engineering teams are increasingly asked to work faster. Speed is absolutely critical to competitive advantage and also to meeting the needs of customers in today's fast-paced economy and society. So where software engineering teams might have once delivered a new version of a piece of software every year or every few months, now they're being asked to deploy or to release a new version of their software every day or even multiple times a day in the case of some software as a service offerings. That pressure for increased speed is only going to get more intense as time goes forward and as staying ahead of the competition requires introducing new features and fixing bugs more and more quickly. But there's a problem. The problem, of course, is security. Software engineering teams are also asked to make their applications be secure, to have a strong sense of where the security problems might lie, and to be able to fix security vulnerabilities very quickly when they emerge. So as velocity becomes more and more important, security also becomes more and more important. And it's hard to reconcile these two. It's hard to envision how you remain secure and fast at the same time. It's fairly easy to think about ways of doing one without the other, but it's really hard to put those two together. How do you do that? That's what we're talking about today. A few years ago, or maybe a decade ago, in the software engineering world, we introduced this idea of DevOps. And that's really about putting development and operations, or software development and IT operations, closer together. Maybe they're not the exact same team, but software developers are doing a few of the things that IT operations teams used to do, and IT ops teams are doing some of the things that software developers used to do, so that companies can set up these kinds of rapid cycles where the planning, coding, and testing kind of goes directly into packaging and releasing and deploying, and then back into planning, coding, and testing. So that there's this cycle that proceeds very quickly. And this is really the key to that rapid development that we talk about when we talk about software engineering velocity. But we still have those security problems. The White House Council of Economic Advisors estimated a couple of years ago that cybersecurity was costing between $57 and $109 billion in 2016. Now, obviously, numbers like this are going to look pretty different in 2020 when the economy is in a very different place. But it's still important to recognize that cybersecurity is actually expensive. It's actually an expensive problem. And we know of those examples of when companies have been breached in a way that has exploited vulnerabilities and released user information. Adobe, eBay, Equifax, Marriott, LinkedIn, Zynga, these are just a few of the big brand names whose brands have been sullied, who've had to incur a huge amount of expense, who've been set back in their businesses because of the release of hundreds of millions of user records. But it's not just large businesses that are impacted by information security problems. More than half of all small businesses suffer a breach every year, but only about 14% are prepared to defend themselves. Information security is a problem that impacts every single kind of business and organization around the world. So how do we break it down into smaller pieces? We actually identify 4 tiers of threats that impact most businesses that do any computing, which is basically all businesses. The first is foundational services. So that's the underlying compute infrastructure, the storage, the database, the network. It's kind of the basis of your application tier. And fortunately, typically, our vendors take care of that. So the vendors that sell the storage, the database, and those different components build that security into that configuration. At the next level is the network level. So network segmentation, perimeter security, this is where your Cisco and your firewalls come in to actually protect your network. Now, a few years ago, when everyone worked in offices and data was all kept in data centers that were owned and operated by the company using them, network and perimeter security was really the vital layer of security. That's really not the case anymore, because now lots of people work at home, lots of offices are very distributed, services are being deployed to cloud infrastructures like AWS and Azure and Google Cloud. And so that network perimeter security is a lot less of a safeguard than it used to be. We really have to focus on those higher tiers. The next tier up the chain, we isolate the virtualization and host layer. So this is your VMware, your EC2, making sure that the operating system security is in place so that the applications that are delivered on top of that are on a layer that's absolutely secure. Obviously, if there's a hole there, there's a problem for your application. But the top layer, and the one we're going to talk about today, is application security. So this is the application itself that your software engineering team is building, along with all of the dependencies and containers that it's built on top of as an entire package. It's critical to make sure that vulnerabilities are identified, remediated, addressed, or at least known in that application tier prior to every single release of software, even if those releases are happening multiple times a day. So how do you do that? Fortunately, there are vendors who sell application security scanning software to help with this problem. Checkmark, Synopsys, White Hat, Micro Focus, these are all companies that sell tools and applications and platforms that perform security scanning in a way that helps you identify where the vulnerabilities live in an application or in an application suite. But there are some problems with these, what we call traditional security vendors. The first is, it's a square peg in a round hole when you try to marry traditional security scanning with DevOps. So DevOps is about moving really quickly. These traditional security scanning tools are about locking down that release before it goes out, which kind of takes you backwards to a more of a waterfall type of process. I like to think of it as a great big padlock right before the release stage. Here comes the security team, a third team in this whole world. Here comes the security team with their security scanning software, and your development team has been working for a couple of months on the new release, and the new release gets sent to security, and security says, there are all these vulnerabilities in this thing. You need to fix them before we can release it. That's the most important thing. And then the dev team has to drop whatever they were planning to do on the next release. They have to go back to the stuff that they were working on days or weeks before, figure out where all these vulnerabilities live, and try and remediate them so that you can get past the security team and over to the ops team in order to deploy. So it's slow, and it causes a lot of friction between different parts of the organization. There's also the problem of not covering all your bases. Quite frequently, the security team is focused on the big door, the front door, and making sure that it's got the 80 padlocks on it, but nobody's paying attention to the little window. The hackers are paying attention to the window. The hackers that are going to exploit the vulnerabilities in your infrastructure are actually looking for those other tools, all those different systems in the dozens, hundreds, or even thousands of different applications that your team is developing and maintaining. So it's important to cover all your bases. So imagine the future. Imagine you can scan all your code every time a change is made in a way that's seamless for the development team. It's just part of their natural workflow that uses fewer tools, not more tools, not just adding layers of tools, but actually less tools, where the dev, sec, and ops teams don't have any more friction, where they're working together in a way that's really seamless, and where your compliance auditors are also happy with the reports and information that they're getting out of that system, that everybody knows the level of security and vulnerabilities are remediated quickly. What if that were possible? Well, it is, and it is by shifting left. Everyone's heard this phrase. We talk about it all the time. This is a software development branching diagram. The bottom line here is the master branch or the develop branch. That's the main line that the software engineering team is all collaborating on. And then the gray line across the top is a feature branch. So that's where either an individual developer or a small team is working on a very specific feature, hopefully for a very short amount of time. Because you're iterating quickly, you want to break your features down into the smallest possible pieces so that things can be merged and delivered on an ongoing basis. That's part of the key to delivering software quickly. In that feature branch, the developers push their code changes and they run their continuous integration or CI. Continuous integration runs their unit tests, their integration tests. It finds a bug, maybe. If it does find a bug, the developers might push some code fixes. They might actually push a bunch of commits during this feature branch until finally that branch runs green. A review app is deployed. A review app is like an ephemeral environment where just the code in that feature branch is deployed so that stakeholders outside the dev team can have a look at it and make sure that it does what they need, meets their requirements. There's maybe an approval process, and then finally that feature branch is merged into the master or mainline branch where it enters continuous deployment. Building and testing happens again, but this time we're actually deploying to production or maybe to a staging environment. By shifting left with your security scanning, you're taking security scanning into the feature branch. So as part of every build and test cycle, part of every commit that gets made, security scans are running. If a vulnerability is found at that stage, developers can address that vulnerability immediately while they're still in their development mode on that particular work. Maybe they introduced a vulnerability. Hey, oops, I introduced a vulnerability. Go back, fix it, commit again. It's all part of their workflow, all part of their process. Now, we're still doing security scans at the later stage. We still have that padlock before release. We're not removing anything from the process by changing over to this shift left DevSecOps approach. But rather, we're adding security scanning into that continuous integration stage, into that verification stage, as a way of giving developers the information that they need to be able to remediate vulnerabilities quickly and hopefully reduce the number of vulnerabilities that get found at the release stage, which is really too late. There are several different types of application security scanning. The most commonly recognized is static application security testing, or SAST. SAST actually reads your code, is aware of the programming language that it's written in, and finds vulnerabilities based on known patterns for vulnerabilities. Dependency scanning looks at all the code libraries and frameworks that the application uses, whether they're in NPM or Maven or NuGet or Conan or whatever dependency management framework is being used, and identifies specific subversions of specific code libraries that might have known vulnerabilities in them, so that you know that everything you're depending on is clean. Container scanning, similar to dependency scanning, but looking at Docker containers or whatever the container layer is that you're using if your application is container aware. Secret detection is looking for passwords and API keys that might have been accidentally committed to the repository. License compliance looks for dependencies whose licenses might violate the main license policy of the application. Dynamic application security testing is actually scanning a running copy of the application. Remember that review app I mentioned? Hey, that's where dynamic application testing can happen. And that's actually trying to penetrate the application. It's actually trying to hack it automatically on your behalf. IAST is sort of a combination of SAST and DAST, where you're hitting it from the outside and also looking at it on the inside. That's pretty advanced stuff, as is fuzz testing, which actually generates fake data to try and break your application. Well, maybe it's invalid or unexpected or random data that could actually surface a vulnerability that isn't surfaced by other traditional means. Now, it turns out that it's possible to run all of these kinds of security testing, security scans, inside a feature branch. This is an example from GitLab, using GitLab CI to run security scans in the feature branch. So this is inside a feature branch. You've got a build stage where your build happens, if there's building to be done, and a test stage. Now, the test stage is running traditional CI jobs like code quality scans and your unit tests and integration tests, but it's also running some of those security scans. There's your SAST, your license management, your dependency scanning, your container scanning. Those can all be run before the application has even been deployed to an environment. If they pass, then the CI job automatically deploys to a review environment, so your stakeholders can now look at it, and your DAST can run. DAST is doing that dynamic scanning, so it needs an environment to actually run against. And only when everything is green can you even think about starting to approve this feature branch for merge. So what does that look like? This is a screenshot of a part of a merge request, which is the GitLab equivalent of a pull request in some other source code systems. The merge request is actually keeping track of the pipeline that is run and the status of the pipeline. But more importantly, this is where approval happens and where the security scan output is. So the approvers who have to approve the merge request before it gets merged get to review the security scan output right there in the merge request without having to switch tools. And if they click into those security scans, they can actually see details about evaluations of how critical that particular vulnerability is. They can actually click those links and make a decision as to how to handle each one of the vulnerabilities that's been found by the scanner in the merge request. They might have three options. One might be to address the vulnerability, in which case the developer goes back, fixes it, another commit happens, another set of scans happen, hopefully it runs green. Or maybe they dismiss the vulnerability, which kind of passes it off to the security team to handle later, presumably because the developer is evaluating that this vulnerability isn't really important or appropriate for this particular application in this context. Another option might be to create an issue for that vulnerability so the team decides not to deal with it right now, but to deal with it later. The point is that all that decision-making and thinking can happen while the developer is still working on that part of the code, so they can do that really quickly and all in one tool set. But just being able to have the developer look at that and work on it is great, but not sufficient to really get that kind of velocity and security that you're looking for. The other thing that needs to happen is executive level reporting. And specifically at the portfolio level, companies that have dozens, hundreds, or even thousands of projects need to be able to see their security posture across that entire portfolio of projects, even while they're still in development. They need to be able to see how many critical and high importance vulnerabilities, high severity vulnerabilities they have, how those have changed over time, and maybe the status of each individual project, and be able to dig in so that staff from development and leadership in development, security, and operations can all get a clear, unified, shared view into the security posture of the application portfolio. Put all of this together and you really get DevSecOps, security as a part of DevOps. So you have the speed and the security working together. It's contextual. It's actually within existing developer workflows, rather than having lots of separate tools, everything in one tool. It's congruent, supporting rapid iteration and innovation, which is critical for remaining competitive in the marketplace. It's integrated. Developers and security teams can file and manage issues, auto-remediate vulnerabilities, track vulnerabilities across the entire lifecycle. And it's efficient, with less tools and context switching and less handing off of things between teams. So does it work? We think so. If a DevOps practice is mature, teams are 3 times more likely to discover security vulnerabilities before code is merged in a test environment. 3 times more likely to discover those. And we asked some of our customers about it. Here are a couple who've just given us permission to mention their names. WAG is a dog walking app. Director of engineering said it's great to have the security baked in. And previously, when their build and deployment process took 40 minutes to an hour, now it only takes 6 minutes. Glimpse is a location application. Their lead software engineer said it's the fastest security vulnerability remediation that he's ever seen in 20 years of working in IT. So I hope this has been interesting and worthwhile. I hope you've enjoyed the talk, and I'm looking forward to our Q&A. Thank you very much for participating.